Marcus, and today I'll be doing a science experiment. It's a super easy experiment that you don't even need a science lab. You can do it at home, in your house, which is exactly where I'll be doing my experiment. First though, we need to go through the basics. You're a human, just like everyone else, standing on Earth. Pretty cool, huh? You have a body. Pretty cool, huh? Most of it is blood. Actually, only some of it's blood. About 4.5 to 5.5 liters, which is just enough to fill a bit more than the amount of milk in a milk jar like this one, except this one is not full, but you get the point here. Now, before I go any further, I just want you guys to know that I won't be going into too much detail here because this is a very complicated topic, but this is oversimplified. So I'll say it like this. The blood in your body is circulating throughout the body, and it will not stop. It'll keep going so that it can keep you alive. It must keep going or else you'll die. If it stops, you die. It'll eventually go through your heart, a fist-sized organ in the middle of your body, right here. But in order to do that, the heart must pump the blood in order for it to go through the heart. But while doing that, the heart creates a beat, and the heart always rapidly beating wherever you go. Have you noticed it? If you haven't, why is that? Well, if you're walking, if you're sitting down like this, you don't feel any beats. But let's say if you're running a marathon or doing some jumping jacks, or you're doing push-ups, sit-ups, treadmill, other exercise like that, you get so tired that you feel your heart beating all the time. And remember, when the heart beats, it means blood is pumping through your body. So 1, 2, 3, 4, 5, that's 5 times blood pumping through your body. But why is that? Why is it when I'm just walking I don't feel anything? Why is it that I'm running I do feel something? What is going on right here? Well, that's what we'll be doing in this experiment. So, the aim of this experiment is to determine the impact of exercise intensity and duration on a person's heart rate and blood circulation in beats per minute, or BPM for short, and the recovery rate as a measure of their overall fitness. My hypothesis that I've predicted is the higher the intensity and or duration of the exercise, the higher the person's heart rate and blood circulation will be in beats per minute, and the faster the recovery rate, the fitter the individual is. Okay, now the variables. There are 2 independent variables. Now, the dependent variable is the variable that changes throughout the experiment. They are the intensity of the exercise in kilometers per hour. In this case is 8, 10, 12, 14, and 16 kilometers per hour. And the duration of the exercise in minutes. In this case is 2, 4, 6, 8, and 10 minutes. Now the dependent variable. That is the variable that we are measuring in this experiment, which is of course the person's heart rate and blood circulation overall in beats per minute. And now the controlled variables. They are the complete opposite of the independent variables, which is the variable that is unchanged throughout the experiment. It is controlled and kept the same during the experiment. There are actually 2 control variables, which are the intensity of the exercise in kilometers per hour at a treadmill incline of 2 degrees for 2 minutes, and the duration set at 2 minutes for the treadmill incline at 2 degrees at 10 kilometers per hour. The materials you'll need for this experiment is a stopwatch, a heart rate app on your phone or tablet. There are several free ones in store. A human subject, it can be you or someone else, and a treadmill and sporting equipment. Now it's time for the method. The first method being intended for the method of intensity, which is the first case of the experiment. So for step 1, you'll need to perform an exercise, which is running on the treadmill, for a fixed duration of 2 minutes at an increasing intensity, and measure the impact of your heart rate using the heart rate app on your device. Step 2, starting at 8 kilometers per hour, use the stopwatch to measure the duration of 2 minutes, after which immediately measure your heart rate with heart rate app. Step 3, wait a further 5 minutes and re-measure the heart rate to determine the recovery rate of your heart rate. And finally, step 4, repeat step 2 and 3 for 10 kilometers per hour, 12 kilometers per hour, 14 kilometers per hour, and 16 kilometers per hour, and note your heart rate immediately following exercise and after a 5-minute recovery period. Entire method for both cases. It's time to get some exercise on the treadmill. Oh, that was tiring. Oh, but at least we've got all of our data required for the results, and now we've displayed that data into a table and on a graph. Just take a look at my results section right now. Now the discussion. The first part we'll be discussing in the discussion is the explanation of the results obtained during the experiment. So the data shows in the results section of the fitness measure duration graph the increase in heart rate after each minute at 10 kilometers per hour and the increase in recovery rate after the end of each trial of the exercise at the 5 minutes. And the results section for the fitness measure intensity graph shows the increase in heart rate after each kilometer for 2 minutes and the increase in recovery rate after the end of each trial of the exercise after 5 minutes. Now the trend line in both graphs are extremely close to the data points, meaning the correlation between the two variables in each graph are very strong. The graph showing fitness measure duration has a correlation of 0.984 for heart rate and 0.9806 for recovery rate. And the graph showing fitness measure intensity has a correlation of 0.9851 for heart rate and 0.981 for recovery rate. Both of the graph trend lines have a very strong correlation between the two variables and all having a very close to full correlation, meaning the data shown in the graph is extremely accurate and appropriate to use for a conclusion to the aim and an answer to whether the hypothesis predicted was right or wrong. The second part we'll be discussing in the discussion is the reliability, which is where we discuss about some suggestions for ways of reducing errors in the nearby future given so that the next time the experiment can run more smoothly than before in order for the data obtained to be more accurate for finding a proper conclusion to the aim and an answer to the hypothesis predicted. So even though the experiment was done steadily and slowly, there were still some mistakes that occurred during the experiment. These experiments may have included personal reading errors from incorrectly reading the figures on the heart rate app and the heart rate app reading written incorrectly on the data, systematic errors from the heart rate app failing to acquire the exact heart rate that was expected to be the outcome, and random errors from random stumbles while performing the exercise and reading the digits incorrectly on the heart rate app after the end of the exercise trial. So in order to avoid such errors in the nearby future, the experimental trials must be double-checked, the equipment must be carefully used, and to repeat the trials if any errors are to be discovered. But overall, the results obtained were very accurate and appropriate to the data as I explained in the explanation, and the data obtained is appropriate to be used in order to make a conclusion to the aim and an answer to whether the hypothesis predicted was made correct or wrong. So what my conclusion to this experiment is that the hypothesis predicted for the outcome of the experiment was indeed correct, which was the higher the intensity of the exercise and duration of the exercise is, the higher the person's heart rate and blood circulation will be, and the faster the recovery rate is, the fitter the individual is. So higher intensity exercises performed help increase a person's heart rate dramatically, causing the blood to circulate around the body faster than before when resting with every beat per minute. Since high intensity exercises are more intense for the body than while it was in its resting state, the heart now has to operate faster in order for the blood to quickly circulate the body, so that the body itself can operate while doing the exercise, resulting in the heart rate and blood circulation increasing dramatically than before in its resting state. This also means that when a person's heart rate recovers quickly, it means that the person is very fit for sport.